Hello students, welcome back. So now we are going to study Python operators, membership and identity operators. Well, the membership operators, there are two kinds. There's in, not in. So they both of them they return a Boolean variable, true or false. So let's check. Let's understand this through an example. Let's say you have a string sentence. This is my sentence, University of Miami, and you want to check if a certain string, if certain substring is present inside this. So you use in operator. So I'm basically asking result equal to Maya in sentence. I'm checking for this substring inside this right here, and I print my result, and it gives me the output true because the word MIA it is present, the substring is present inside this whole sentence. Okay, what about Maya not in sentence? Think of not in as the opposite of in. So whatever your in is producing is gonna reverse it. So if it's true, it's gonna make it false. If it's false, it's gonna make it true. But in this case, Maya in sentence produced true. So Maya not in sentence is going to produce false. It's basically checking if Maya is not in sentence. Well, that's not true. Maya is in sentence. So it produces false over here. Okay, now let's change MIA to small MIA. I'm just changing the letter now. So instead of using capital M, I'm using small m over here. This one right here is a small m. So in this case, is small MIA in sentence? Well, the answer is no, it is not in there. So it's going to produce, it's going to return false right here. And you can see it returns false. So if this returns false, then I'm checking Maya not in sentence. Is this true? Well, that is true because this string small MIA is not present inside this. So that's why it returns true over here. Well, let's check if an element is present inside a container. So we use in operators to check whether an element is part of a container or not. So these containers could be a list, could be a tuple, could be a set. So let's start with the list. So let's say my data equal to list 1352. This is my list right here because it's a square bracket. So you can tell it's a list. Okay, so I want to check if my 1 is present inside data. Well, 1 is present inside data. So if I run this and you can see it prints out true. So 1 in data is true because the element 1 is present inside this. How about element 7? Is 7 present inside this? Well, not really. So you can see it prints out false. Okay, so we did this thing with the list. Now let's do this thing with the tuple. Same logic happens to the tuple. So you can check if an element is present inside a tuple too. Okay, this is going to be present true over here because 1 is present inside this. On the other hand, 7 is not contained inside this. Okay, how about a set? We can do the same thing with a set. So this is my set right here. You can see the set bracket. Okay, the curly braces. So is 1 present inside data, inside the set? Well, it is present. So it prints out true. What about 7? Is 7 contained inside data? The answer is no, it is not. It prints out false. You can also check if a certain key is present inside a dictionary. So this is my dictionary right here, dictionary. Okay, oh, look at the spelling. Made a mistake in spelling. All right, dictionary. So let's say my data equal to this right here. This is my data. And I have Ram 34, Carlos 53, Tom 22. So I'm checking if ROM in data, in other words, is the key ROM present in there? Well, when I run this, the answer is true. It is present in there. How about small RAM? Well, that's not present because it is case sensitive. So capital RAM and small RAM are treated different. In this case, it prints out false right here. It is not present. Then there is an identity operator. So there are two of them, is and is not. This one essentially checks if two variables refer to the same memory location. So it checks for the memory location. It does not check for the value. Now, this one checks the difference between is and this operator with double equal to is that this one checks whether two values are equal. Okay, it compares the contents and the values, not whether they are the same object. Is, on the other hand, what it does, it checks if the two variables point to the same object in the memory. In other words, are they living in the same memory address? That's what this is checks for. It always returns a true or false. In other words, it always returns a Boolean variable. So let's say my A equal to 3 and my B equal to 6. A is B. Basically, I'm checking is A and B are they living in the same memory location? Let's find out. And the answer is false. My A and B, they are not living in the same memory location. They are living in different places. How about A is not B? Well, in this case, is not would be the opposite of that. So if this is printing true, this is going to print false. Well, in this case, it prints out true because A is not living in the same place as B, which is true. Okay, so I can also determine, by the way, where exactly they are living. So you can use this ID, this function, this method called ID. And if you look at the value of ID for 3 and ID for 6, this is exactly same data. ID for 3 and ID for 6 is going to kind of tell you, it's going to tell you the memory, almost like it maps the ID. What it does, it maps this number to the memory location. So the memory location of A is this right here, and the memory location of B is this right here. And you can see that the memory location of A and memory location of B are not same. That's why it's printing when A is B is printing out false. Okay, so generally just thought you should know that Python always stores the small number at the same memory address. So let's say I say a equal to 3 and I type b equal to 3. These are very small numbers. So now if I try to ask what is a is b, it's going to return true. Okay, a is b because they both are living at the same memory place. By the way, if you check the ID of a and ID of b, you can see that they both are essentially living exactly the same place. But now, if I do the same thing, okay, I'm doing the same thing, but I'm changing the numbers. So I'm changing the numbers to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Exactly same number. These two numbers are same. The only difference is instead of writing 3 now, I made them very big number now. Okay, very big. So by making these big numbers, now I'm asking the Python, hey, are they living in the same memory location? And the answer is no, false. And what Python does, it stores the big numbers at different memory addresses. Be mindful be mindful of that. Okay, so two variables living at the same memory address. So let's say my a equal to this number, right? It's a big number. And now I'm saying b equal to a. So basically what I'm doing, I'm saying that the address of b is same as the address of a. So now if I print a is b, it's going to print true because now my a and b, they're exactly living in the same place because of this line right here, okay? B equal to a. You can check the ID of A and ID of B, and as you can see, they're exactly same. They're identical. Uh, let's take a look at two lists. So I have a list. This one contains 1, 2, 3. This also contains 1, 2, 3. So I'm checking. Are these lists same? Well, in this case, true, because what it does, this expression right here is checking content-wise. It's checking each and every element. This, on the other hand, is checking are they living exactly at the same place? And the answer is no, they are not living at the same place. Their memory address is different. That's why it prints false. Thank you.